There is a good chance that right now, wherever you are looking at a QWERTY keyboard on your phone, your laptop, or the tablet propped up next to your coffee. That keyboard was designed in 1873 by a man named Christopher Latham Sholes. And here is the thing about it. The mechanical typewriters of the era had a persistent, maddening problem. If you typed too fast, the keys would jam. So Sholes rearranged the letters to separate the most commonly used pairs, giving each key time to fall back into place before the next one struck. It worked. It also made typing slower and more effortful than it needed to be. Now, you might assume that once the mechanical jamming problem was solved, once computers arrived and keys no longer jammed for any reason whatsoever, we would naturally migrate to something better. In 1932, a researcher named August Dvorak designed a layout built to reduce finger movement and fatigue, and most people who have tried it report it is noticeably more comfortable. It should have won. It turns out, it did not come close. QWERTY survived not because it was right, but because it got there first, spread widely enough, and became too embedded to displace. Every typist already knew it. Every manufacturer built for it. Every school taught it. And learning a new layout felt like more trouble than it was worth. That is what a dominant design looks like. Not the best solution. The solution that reached critical mass. Which brings me to the question I want to start with today. In artificial intelligence, in 2026, who is the QWERTY? And the honest answer, the one that business media rarely leads with, is that we genuinely do not know yet. In 1975, two researchers at MIT, William Abernathy and James Utterback, published a landmark analysis of how innovation actually unfolds in technology industries, a framework that has held up remarkably well across 50 years of technological change. Their observation was elegant. Every technology moves through three recognizable phases, and the strategic choices that make sense in each phase are almost completely different. The first is the fluid phase. This is the wide-open period when multiple competing designs exist simultaneously, nobody knows which will win, and companies are making genuinely different bets. The early automobile industry was like this, before anyone agreed on where to put the steering wheel, before the internal combustion engine locked in, before petrol stations existed. The early home video market was like this, when VHS and Betamax were genuinely competing. Possibility is high. Commitment is dangerous. The second is the transitional phase. A dominant design begins to emerge, not necessarily because it is the best, but because it has reached critical mass. Network effects accelerate it. More users attract more developers. More developers attract more users. Standards form around it, and competitors either adopt it or get squeezed out. The third is the specific phase. The design is locked in, and competition shifts from innovation to efficiency. Who can deliver the dominant design faster, cheaper, and more reliably? The window for differentiation has closed. You are now in an execution game. Here's the twist. By every available measure, artificial intelligence in 2026 is still firmly in the fluid phase. The model landscape is genuinely unsettled. You have OpenAI's GPT family, Anthropic's Claude, Google's Gemini, Meta's Llama, Mistral from France, and then, the detail that tends to surprise people the most, Chinese models now account for up to 46% of enterprise token usage in the United States, up from under 5% in the first half of 2025. Pause on that for a moment. Nearly half of all enterprise AI workloads in the world's largest economy are running on Chinese infrastructure. That is not the race narrative that most business media would have you believe. The economics here are extraordinary. DeepSeek's most capable models cost roughly 60 to 90% less than their US equivalents, while matching them on many agentic benchmarks. If we're being completely honest, the US winning the AI race story and the actual purchasing behavior of US companies are currently pointing in rather different directions. For anyone making strategic decisions about AI right now, this is not a footnote. It is a diagnostic. The fluid phase rewards flexibility. Betting everything on one provider, one model, one ecosystem, when no dominant design has emerged, is a structural risk that the framework makes very clear. Before we get to how companies should respond, it is worth briefly establishing the scale of what is actually at stake, because the dominant design question plays out simultaneously at 3 levels, and conflating them is a common mistake. At the micro level, this is about individual organizations, one hospital, one retailer, one logistics firm, making an AI investment and measuring what they get back. Most ROI conversations happen here, and we will spend significant time in this territory in the chapters ahead. At the meso level, it is about entire industries. When AI restructures how legal work, or medical diagnosis, or financial services operates, the competitive dynamics of that industry shift in ways that go beyond any single company's spreadsheet. At the macro level, it is about economies and societies. AlphaFold, developed by DeepMind, did not simply help one pharmaceutical company. It restructured how protein research happens globally. In October 2024, the Nobel Prize in Chemistry was awarded partly in recognition of the science AlphaFold had made possible. That is a macro-level effect, and it happened within a decade of the technology being conceived. These 3 levels are connected in important ways. A dominant design does not just change one company's costs, it restructures an industry. And enough industries reshaped by the same technology become a macro-level transformation. Keep that perspective in mind as we go, because every framework in this module is ultimately asking the same underlying question. How do you position yourself to create and capture value when the technology is still moving this fast? Let me tell you about IBM Watson for Oncology, because it is exactly the kind of story that tends to get quietly filed away once the press cycle moves on. In 2011, IBM's Watson system famously beat the world's best Jeopardy players, and IBM, understandably excited, decided to turn that capability into a healthcare business. The pitch was compelling: an AI that could analyze a patient's records against the entire published literature on oncology and recommend treatments. It was the first major AI health product of its kind. Memorial Sloan Kettering Cancer Center trained the system. Hospitals around the world signed on. In 2016, the University of Texas MD Anderson Cancer Center halted its project. $62 million spent, no clinically usable system. Internal documents reviewed by Stat News in 2017 revealed that Watson had been recommending treatments oncologists described as unsafe and incorrect, including chemotherapy combinations that could cause fatal hemorrhage. The software had been trained on a small set of synthetic, hypothetical cases rather than real patient data, and it simply could not generalize. By 2022, IBM sold off the entire Watson Health division. Total investment? Over $4 billion. IBM Watson for Oncology had every first-mover advantage the textbook describes: the brand, the capital, the partnerships, the head start, and it failed, expensively, quietly, and in a way that has largely been absorbed by the narrative of pivoting to different AI opportunities. Now, you might assume from reading the business literature that first-mover advantage is, on balance, a reliable predictor of success. Marvin Lieberman and David Montgomery's 1988 paper makes a genuinely compelling case. First movers can lock in resources, build switching costs, move down the learning curve faster than any follower, and define what the product category means in the customer's mind. And when the conditions are right, all of that is real. Amazon built logistics infrastructure before anyone understood what was happening. Netflix defined streaming before cable companies could respond. Google built a search index at a scale that took years for anyone to approach. Here's the twist, though. We remember those stories because they worked. We tend not to dwell on the IBM Watsons of the world, or on the fact that MySpace was first, that Blockbuster had an internal streaming option before Netflix launched, or that the original smartphone app stores were not Apple's. If we're being completely honest, there are probably as many first-mover train wrecks as there are first-mover success stories. We just suffer from a collective case of survivorship bias. The honest version of first-mover advantage sounds more like a conditional. Being first can create durable competitive advantage if the technology is genuinely ready, if your capabilities match the specific application, and if you can build switching costs before a better resourced competitor catches up. Remove any one of those conditions, and being first mostly means you pay for the market's education. So where does that leave business leaders in 2026? It turns out that Utterback and Abernathy's framework offers something more useful than a prediction. It offers a diagnostic. And the diagnostic question is straightforward. What phase is the specific AI application you are considering actually in? If the answer is fluid, multiple competing tools, no clear standard, rapid capability improvement, then the premium is on flexibility. Build for optionality. Avoid deep vendor lock-in. Stay close to the technology curve and treat any AI contract with meaningful switching costs as a structural risk. This is where most enterprise AI investment sits right now. If the answer is transitional, a dominant design is visibly emerging in your specific use case, then the window for competitive differentiation is narrowing and the logic shifts. This is the moment to move with conviction, because the design is locking in around you, and the companies that commit now will shape what standard looks like. And if the answer is specific, the technology is commoditized. Everyone has access to essentially the same tools at similar price points. Then the competitive question is no longer about the AI at all. It is about your data, your processes, the people who know how to use it, and your capacity to execute better than anyone else with the same inputs. The race is not over, but it will not stay open forever. And knowing which phase you are actually in is the beginning of a real strategy. That is the landscape, the fluid phase, the first mover question, and the 3 levels at which it all plays out. What none of this tells you is how to win once you have diagnosed where you are. For that, there is a framework that has been around for 45 years and turns out to be surprisingly well-suited to thinking about AI competition. And alongside it, some research from BCG that cuts through more noise than almost anything else published in this space. There is also something else, a pattern in how companies are actually deploying AI right now that does not appear in the theory at all. We will get there before this module is done. Stay with me. Somewhere right now, there is a board meeting happening. And if I had to guess, it looks something like this. A slide appears on the screen with AI strategy in confident letters at the top, beneath which sits a roadmap divided neatly into 3 phases: explore, scale, and transform. The phases are connected by arrows, and the arrows, meaningfully, all point to the right, toward the future, where things will presumably be better. Around the table, people are nodding. The CEO is nodding. The CFO, who was not entirely certain what the meeting was about when it went into the diary, is nodding along. A board member has flown in from another city specifically to attend this nod, and is doing so with particular conviction. What is somewhat less clear to anyone in that room, if we're being completely honest, is what problem the AI is actually solving. But the competitor's annual report mentioned AI 14 times, and right-pointing arrows have a remarkable ability to project confidence even when the destination is left deliberately unspecified. Michael Porter, who has spent his career studying exactly this kind of moment, would have a great deal to say about that meeting. Porter is a Harvard Business School professor who, in 1980, published a framework called the 3 Generic Strategies. It is 45 years old. It is also, I would argue, more useful for thinking about AI investment decisions in 2026 than most of the AI-specific strategy research published in the last 3 years. Because his central insight was not about any particular technology. It was about the fundamental nature of competitive advantage itself. There are, Porter argued, only 3 ways to build a durable competitive position. Companies that try to pursue all 3 simultaneously, or none of them deliberately, end up stuck in the middle, squeezed by specialists on every side with no distinct reason for a customer to choose them. Let us look at all 3 through the lens of what is actually happening in the AI market right now. Cost leadership means becoming the lowest cost producer in your industry. Not necessarily the cheapest for the customer, though often that too. The goal is a cost structure that nobody else can sustainably match. In the AI model market, the clearest live example is DeepSeek. And the numbers here are worth sitting with for a moment because they are genuinely extraordinary. DeepSeek's most capable models cost roughly 14 cents per million input tokens. OpenAI's GPT 5.5 is priced at $5 per million tokens. That is not a rounding difference or a product tier distinction. That is a 35-fold gap between 2 models that land within a percentage point of each other on many enterprise benchmarks. The economic logic for a business running significant AI workloads is almost uncomfortably straightforward. It turns out, US companies have noticed. As we covered in Chapter 1, Chinese models now account for up to 46% of enterprise token usage in the United States. Coinbase cut its AI spend nearly in half by routing agents to Chinese models. Lindy, an AI automation company, moved 100% of its traffic from Anthropic's Claude to DeepSeek. Now, if we're being completely honest, there is something important to acknowledge here. DeepSeek's pricing is partly possible because of significant Chinese state support, subsidized compute, preferential data access, and a structural cost environment that a purely commercial company operating without government backing could not easily replicate. This is the same playbook China used to build its electric vehicle industry, and whether the pricing is sustainable at scale without that support is a genuine open question. But as a demonstration of cost leadership strategy operating in real time, in one of the most competitive markets on Earth, it is working. The 35-fold gap is real. The market share is real. And any AI strategy discussion that ignores the cost dimension because it feels geopolitically inconvenient is not a strategy discussion. It is a comfort exercise. Underneath the pricing story is a set of architectural choices, documented in academic work on AI business strategy, including research by Story and colleagues, that have changed the unit economics of enterprise AI in ways the per-token price comparison only partially captures. RAG, or Retrieval Augmented Generation, connects a model to a live knowledge base at query time rather than baking proprietary knowledge into expensive training runs, keeping AI current on internal information at a fraction of traditional cost. ICL, or in-context learning, allows a model to adapt to new tasks from examples provided in the prompt itself without updating its weights, meaning organizations can customize AI for new use cases at near zero marginal cost per adaptation. Together, RAG and ICL explain much of why a well-architected AI system can operate at costs that make DeepSeek's pricing logic replicable across domains beyond model provision. The third development is LAMs, large action models, and this is where the risk calculus changes entirely. LAMs do not generate text for a human to then act on. They execute actions directly inside live business systems: booking, filing, updating, ordering, triggering workflows. That is the transition from AI as advisor to AI as operator, and it is a substantial shift in both the value profile and the governance requirements. The efficiency potential is real, so proportionally, is the consequence of an error. Both need to be on the business case. More broadly, cost leadership through AI across industries flows through a consistent set of operational levers. Process automation reduces labor cost in repetitive tasks across back office, logistics, and customer service functions. Predictive maintenance detects equipment failure before it happens, eliminating unplanned downtime that costs more per hour than any maintenance program. Energy efficiency gains from AI-optimized systems, building management, data center cooling, manufacturing line control, reduce operating costs at scale. And supply chain optimization compounds all of the above by reducing inventory waste, shortening lead times, and synchronizing demand signals with production capacity. DeepSeek's pricing story is cost leadership at the model layer. These are the mechanisms that make cost leadership real at the operational layer of most businesses. Differentiation means offering something genuinely distinctive that customers will pay a premium for. Not just different for its own sake, meaningfully, credibly better in a way that matters to the specific people buying it. Anthropic's Claude is a reasonable example. Here's the twist. The differentiation is not raw capability, because on many benchmarks, Claude, GPT, and Gemini are remarkably close. The differentiation is trust, safety, and enterprise governance, constitutional AI, interpretability research, and a company that has made safety its founding argument rather than its compliance obligation. For organizations operating in regulated industries, finance, healthcare, legal, that is a real purchasing reason. And it is not primarily about the model's output quality. It is about what happens when something goes wrong, who is accountable, and whether the audit trail holds up. Anthropic's differentiation is built for exactly that conversation. Apple offers a similar example from a different angle. Apple has consistently declined to lead the AI capability race, positioning its AI features instead around on-device processing. Your data stays on your device. In a world where AI privacy concerns are rising and enterprise data governance is increasingly scrutinized, that is a differentiation strategy applied to AI with some discipline. What does AI-enabled differentiation actually look like at the operational level? The recurring patterns are advanced analytics capabilities that surface insights from proprietary data that competitors using off-the-shelf tools simply cannot access, pattern detection, risk signals, market intelligence embedded in data only you hold, and superior customer service. Not just faster responses, but AI that understands a customer's full context and history, producing interactions that create genuine loyalty rather than mere satisfaction. These are the mechanisms behind Anthropic's differentiation thesis, and Apple's as well, even though neither company would frame it quite that clinically. The risk, as Porter was clear about, is that differentiation must be actively defended. If the trusted, safety-focused model and the 35 cents per million token model converge on capability, the cost advantage will exert enormous pressure on the premium. Differentiation strategies have to keep earning their position, which is, of course, part of what makes them genuinely strategic. Focus means selecting a narrow segment and serving it more completely than any generalist ever could. A specific customer group, a particular use case, a problem with genuine depth. This is where AI has its highest success rate, and it is consistently underappreciated. Harvey is a legal AI company, now valued at $11 billion as of early 2026. It does not try to do everything. It does legal work, contract review, due diligence, regulatory analysis, with a depth and domain specificity that general-purpose models cannot match for that application. Law firms pay a premium for it precisely because it is not also trying to write marketing copy and plan business travel. AlphaFold, developed by DeepMind, is the canonical example. It does one thing: predict the three-dimensional structure of proteins from their amino acid sequence. It does it better than any human researcher and faster than any previous computational method. And the Nobel Prize in Chemistry in 2024 was awarded partly in recognition of the science it made possible. It did not try to be a general intelligence. It solved a specific problem completely. Bloomberg GPT is trained specifically on financial data for financial use cases. Cursor is a coding assistant. The pattern is consistent. The narrower and deeper the application, the better the chance of building something genuinely defensible. The more a company says, "Our AI does everything," the more likely it is to do nothing particularly well. The mechanisms that make Focus defensible are worth naming as individual arguments, because each one compounds the others. Target marketing built on proprietary segment data that generalist providers simply cannot accumulate because they serve too many industries to go deep on any one. Predictive analytics calibrated to a particular sector's specific failure modes and decision cycles rather than averaged across every industry at once. Customer insights that deepen the longer you stay focused, becoming more valuable over time precisely because they represent something a new entrant cannot replicate from a standing start. And product development driven entirely by problems that one customer group faces, creating solutions that nobody else builds because nobody else knows the problem at that depth. Harvey has all four of these for law firms. A general-purpose AI assistant, by definition, has none of them. Porter called the failure mode stuck in the middle, and it is the place most AI investment quietly ends up. Not cheap enough to win on cost, not distinctive enough to command a premium, not focused enough to dominate any segment. A general-purpose chatbot deployed for customer service, selected because the CEO asked about the AI strategy and someone needed an answer, running at roughly the same cost and capability as 3 competitor equivalents. The arrows pointed to the right, but no position was chosen. For executives, the diagnostic question Porter's framework really asks is this: which of these 3 positions are you actually building toward with this investment? And is the AI you are deploying genuinely serving that position, or is it serving the need to have something to show? Those are different questions, and they tend to have different answers. Now, here is the problem with Porter's framework as a practical guide to AI investment. It tells you where to position yourself. It does not tell you how to distinguish between AI that actually changes your competitive position and AI that merely creates the impression of one. For that, there is research from BCG that I find more practically useful than almost anything else written about AI strategy in the last 5 years. Francois Candelon is a managing director and senior partner at the Boston Consulting Group and global director of the BCG Henderson Institute. He and his colleagues spent several years studying what actually separated AI leaders from AI laggards, companies that created measurable value from AI versus companies that had significant AI activity and very little to show for it. The finding was straightforward enough to sound almost too simple. The companies that led started with a problem. The companies that lagged started with the technology. Candelon's framework draws a clear distinction between what he calls table stakes and golden use cases. And making this distinction vivid, I think, is one of the more useful things this module can do. Table stakes are the AI applications that every company in your industry will eventually deploy. Automated customer service, AI-assisted document processing, email drafting tools, basic demand forecasting. These applications reduce costs and improve efficiency, and that is genuinely valuable. But they do not create competitive advantage because your competitor is deploying the same tools from the same vendors at roughly the same time. It turns out, this is not a new problem. Think of having a website in 2005. If you did not have one, you were behind. If you had one, you were not ahead. You were simply not behind. Table stakes is the price of admission, necessary but not sufficient. Golden use cases are different in kind, not just degree. These are AI applications built on something a competitor cannot easily replicate. Proprietary data accumulated over years, a specific operational capability, deep domain expertise, or a problem that is uniquely yours to solve because of who you are and what you know. These create genuine differentiation, because the AI is not doing something everyone else is also doing with the same inputs. It is doing something only you can do in this particular way. The example that makes this most vivid is Profluent Bio. They used a protein language model called ProGen to do what they called inverse drug design. Conventional drug discovery works by testing molecules to find ones with desired properties, a slow, expensive, high failure rate process that has governed pharmaceutical research for decades. Profluent inverted it. They designed molecules with specified properties from scratch, then synthesized and tested them in the laboratory. Of 100 candidate sequences, 75 showed the desired functional activity, performing as well as proteins found in nature, despite being sequences that nature had never produced. The AI was not making the existing process faster. It was enabling a process that did not previously exist. That is a golden use case. The value is not incremental, it is structural. For any AI investment on the table right now, the most useful question a CFO or executive can ask is a simple one. Is this table stakes or a golden use case? If it is table stakes, useful, necessary, must do, then the strategic question is not whether to do it, but how fast and how efficiently it can be done well enough. The competitive advantage will not come from the AI itself, it will come from execution, speed, and cost discipline. If it is a golden use case, AI applied to something where you hold a genuine, hard-to-replicate advantage, then the strategic question is entirely different. Are you protecting and deepening the proprietary data, the domain expertise, and the specific operational capability that makes this application better than anything a competitor could build from a standing start? Most organizations, if they are honest, are mostly deploying table stakes. That is not a failure. Table stakes needs to get done, but calling it a strategy, dressing it in right-pointing arrows and presenting it as a competitive position, is where the expensive confusion tends to begin. Porter identified the same failure mode in 1980. He just did not know he was describing something that would still be showing up in AI board presentations 45 years later. His later work made a point that applies as directly now. Sustainable competitive advantage is never a fixed state. It requires continuous innovation and adaptation within a chosen position. The organizations that lead in AI are not the ones with the best deployment on a given date. They are the ones still building the capability that makes next year's deployment better than this year's. So now you have the landscape and the lens. A fluid phase technology where no dominant design has emerged. 3 ways to build a competitive position, and a clear distinction between AI that is the price of admission and AI that is genuinely transformative. Here is the thing, though. None of this tells you what the investment is actually worth. And measuring that turns out to be, and I mean this with genuine conviction, one of the more philosophically interesting problems in business right now. Not because the value is not real, because most organizations are measuring it with the wrong tool, on the wrong timeline, against the wrong baseline. And the gap between what is being measured and what is actually happening is large enough to explain something that initially sounds absurd. How executives can be at maximum AI investment, approving every business case, expanding every team, and simultaneously be unable to point to a measurable financial return. There is also a specific framework that makes that paradox suddenly click into sense. The clearest taxonomy I have found for why the numbers look the way they do and what to do about it. I will introduce it when we get there. That is Chapter 3. In a recent Gartner survey of corporate healthcare provider executives, more than half of them, 56%, named software and technology as one of their top 3 strategic priorities. Not a side project, not a pilot, their number 1 focus area, competing for budget alongside everything else that keeps a healthcare organization running. They are doubling down. expanding teams, approving business cases, building roadmaps. And when you ask the same executives what their AI investments have actually returned, in measurable, auditable, reportable financial terms, the answer gets significantly quieter. Technology is the #1 priority. What it is actually worth remains an open question. Now, you might assume the problem is the technology itself, that AI simply has not delivered what the hype promised. And there is some truth in that. But I think the more interesting explanation is sitting just underneath it, which is that most organizations are measuring the wrong thing, or measuring the right thing with the wrong tool, or not measuring anything at all and then being surprised when they cannot find a number they never defined.